Okay, and part two of the homework two, we're dealing with a cross-docking facility. It's a warehouse and inventory technique, meaning the parts coming in through the receiving docks, and if there are demands or truck available, we directly, receive from one side of the dock and cross over and then deliver to the other side of the loading dock and ship out directly. And these type of technique we usually referring to as cross-docking. And if the delivered truck actually for the downstream is not available, and these inventory we receive is going to send it to warehouse and for future deliver use, future retail store. So here we're dealing with a refrigerator, a large truck, semi truck coming in, arrive at the west side of the dock, and these refrigerators are sent to different retail store. And if there are delivered trucks already on the east side of the dock, and then we just send it out as it is. However, if the delivered truck is not available on the east side, east bay, then we're going to temporarily put these refrigerator we're unloading into a warehouse, and later on the delivered truck come in, then we're going to retrieve them from warehouse. There's a major difference between directly cross-docking or using warehouse. And cross-docking is just moving from one side of a loading dock to unloading dock to another side of the loading dock. So it's quite easy, and there's no less overhead to move things around. However, if the the refrigerator already into the warehouse, it takes some more time actually to retrieve them later on, and also it takes a longer time to store them and store them in the warehouse. So this is pretty much what we have, and the west side of the loading dock is over here. You can see is unloading, and then if there's a loading dock on the east side, then we just directly go ship out. Otherwise, these refrigerators go into the warehouse, and later on, when delivery truck coming in, we unload them, retrieve them from the warehouse. Okay, so the large truck, a semi truck arrive in warehouse dock following uniform distribution between 160 to 250 minutes inter-arrival time. And let me see if I just built it this morning. Small, easy one, just show you how these things look like in a second. Each one of the semi truck carries 64 refrigerator. It requires a total of 15 to 35 minutes, most likely 25 minutes based on per distribution to unload them from the semi truck. If the delivered trucks are available at the east side of the bay, the refrigerators are taken directly to the delivered truck dock and load them on the truck. It requires about 10 to 20 minutes to most likely 15 minutes to load the entire truck. And each one of the 4 delivered truck can take about 8 refrigerator. Once the delivered truck is loaded, they send it to the customer or retail store and come back within 40 to 70 minutes based on uniform distribution. So this is a very straightforward couple things. If the delivered truck is are waiting in the cross dock, then some of the load, actually total of 8 refrigerator per truck, and will be stored at the staging area at the cross dock, while the rest of the refrigerator, since each time is 64 of them coming in. Okay, so they're gonna get to send it to warehouse. It takes about 10 to 14 minutes. with a most likely 12 minutes based on per distribution. In general, the number of refrigerant take to cross-dock is equal to the total capacity of the delivery truck waiting at the cross-dock, plus 8 of the staging area, which is the new truck. So we're just sending 8 extra. Then minus the number of a refrigerator en route to the cross-dock already, plus the number of refrigerator at the cross-dock already. So these are the number of refrigerator once they unloaded from the semi-truck, how many. However, the big truck can unload without conflict with the cross-dock, so there's no personnel sharing or capacity sharing between west side of the unloading side and the loading side. One thing is when the delivery truck come back, when the delivery truck return to the warehouse after delivery, the truck will be first retrieve items from the cross-dock if there's any in the cross-docking. Okay. Just a second. Let me resize the window a little bit. All right. So, or otherwise, it's going to, if there are no refrigerator in the staging area, and the delivery truck will retrieve from the warehouse, taking about 20 to 35 minutes, most likely 25 minutes. If there's no item waiting in the warehouse is empty, and then the delivery truck will go to the cross-dock to wait for the future arrival. Okay, so here we do the basic model first. We're not intended to do everything together. Let's just start from scratch. I'm going to show you what I have already. And from this morning, I got up a little bit early, practiced myself. I think is pretty straightforward, so it's not too difficult. So here what we have is the source. Actually, did it pretty quick. The semi-truck coming in. If you look at the semi-truck coming in and unloading the load, okay, either they, the truck, then once they unload, they leave to the sink. So they're going out this way. But the unloaded refrigerator, actually we have a refrigerator right here in the green, and goes to 2 possible route. Depends on how many delivery truck you have, and then you take that portion into the cross-dock. And the extra ones and goes to the warehouse for storage. Okay. And the delivery truck I illustrated here, I have 3 of them, and your problem has 4 of them. And just generate from the source, actually, and comes to here and pick it up the refrigerator. Each one of them pick up a so-called 8 of them. Here I'll show you how I'm using a property variables and property model property and to determine what is the truck size. Okay, and after the deliver truck pick up the refrigerator, they go to deliver. Here what I do is I'm using a separator to simulate the unloading at the customer side, and all the refrigerator go to the sink. Then go back, and the delivery truck recycle back, return, and determine the condition we have. Determine first is if there's still refrigerator in the loading dock staging area, I go ahead to come here to pick it up. If the loading dock, the cross-dock staging area is empty, then I go to the warehouse. But if the warehouse is also empty, I then decided to go to cross-dock to wait. So these are the logic, basically. Any question for this? Okay. If not, I'm going to start building from scratch. Sure. Say that again. I didn't. Uh huh. Yes, yes. It's kind of not very loud, but I can barely hear it. That's we're using the separator. Okay. Demonstrate that in a minute. Okay. So every time the truck coming in reach this separator, it makes a copy of whatever the truck capacity times 8. Okay. So the truck, I have how many truck over here? So A times A is 64. Okay. And I created, make copy of the entity refrigerator right here. So they goes downstream either to a warehouse or to the cross dock. Make sense? Okay. We go over that in detail. But right now, I'm just trying to see if, if the whole picture, the logic is once the truck coming in, I'm using a separator. This separator used to be just separate, combined entity, but separator can also, instead of using it as a, split batch, I can using for create copies, basically duplicates and make copies instead of making copy of this semi truck. Actually, I'm making copy of the refrigerator. You understand what I'm trying to say? So that's the entity type is an entity refrigerator, and the truck after they got separated and goes out the parent output node and leave the system. Okay, so I'm quickly running this for you. I built it this morning. So the truck coming in reached the separator, and then you see according to how many truck we have here waiting, I split that batch 64 into, you know, uh, 24 and rest of them. And you see how many inventory we have on each site. And then once the truck is loaded, then they go this separator to simulate unloading at the retail side or the customer side. And then this truck is recycled back to the system. And now since loading dock is empty, I'm trying to go to the warehouse and get it. Make sense? Okay. So here I'm gonna stop this, start from scratch real quick. Need a couple saws, at least two. One for the semi truck, one for the. So the source one is generating the semi truck, a large truck arrival. Then I'm going to using a separator to simulate the unloading process of the semi. And in between, there's a time path going on. Okay, what is the time? Actually, is about 30 minutes. I'm going to give it to. Okay, so here. 30 minutes straight. I can use other distribution, and then I'm using a sync to simulate after they get separated, this thing going back out as leaving process. I'm using this also 30 minutes. Just sync. Okay, and this separator actually I'm doing is I'm trying, instead of a split a batch, since we never batch anything, instead I'm using making as a duplication. here I have is 64. So I basically create a 64 copy of something, okay? But here I don't have anything. I'm just going to bring in a several entity over. This is going to be my entity semi-truck. Okay. And this one is going to be my entity deliver truck. I'm going to let you figure out most of the detail. I'm just giving you a framework today. So just please follow the idea, what I do. Over here, and I need one more. I need one more entity, basically is the entity fridge. Okay, these are the entity fridge. And when I make a copy of 64, basically I using entity fridge. Make sense? So this semi-truck coming in this way, got make original come out this way, go to the sink. The rest of the fridge they make copy with, okay, going to the member output. Okay, so the member output, I have to using a combiner at the crossdock and the combiner at the warehouse, for example. And I'm going to call this guy combiner crossdock. And this will be, actually, if you can follow what I'm doing, you are almost done with your homework. Okay, it's not that difficult. I do it slow, maybe a little bit faster than you can catch, but however many steps you can follow, you'd be better off that way. All right, the refrigerator actually come in this either to the member of this crossdock or the member of the warehouse. So I need to have a decision node somewhere to determine which way they go. Instead, I'm going to using a transfer node, okay? And here I'm going to using time path to connect them all together. Okay, so determining the path for the refrigerator now. Now I'm going to determine the path for the deliver truck. Okay, so the deliver truck actually come in from the source to the parent nodes right here. Okay, and then initially for warehouse, they don't go directly to warehouse. Whenever they return, they have another chance to go to warehouse to pick up. So initially they just arrive to the cross-dock combiner and try to pick up over here. Question for me so far. Once the combining is done, I'm going to using another separator downstream. I'm going to assuming, oops, sorry. Go to the separator and then do with that later. For separate the combined, so this will be just split batch, whatever, and doesn't matter. And the one got split actually goes to a sink. And we call this sink customer. Okay, and here I'm just using a connector to connect them, meaning simulate they're being unloaded. And the rest of the and the deliver truck actually circle back to either go to warehouse or go to the combiner. So this is a similar situation. Adding a transfer node again. I'm using a couple time path. So out of this, okay, out of this parent nodes of the separator that apparently the deliver truck going to here either goes to the parents of the warehouse or goes to the parents of Crossdock. Depends on the situation. Make sense? Okay. And since this is a time pass, you probably found the homework assignments and you can easily figure it out. This is what travel time is. Random, distributed, uniform, between 40 to 70 minutes. Make sense? I do the easy part first. I'm not hurry on anything. So over here, the batch quantity is the first thing I want to determine. Is actually batch quantity over 8. Okay, batch quantity of 8. So what I need trying to do is later on I want to determine how many per truck opposed to low. So what I do here in this example, I'm just going to show you, and I'm going to create an integer property over here. Like I said, property is almost like a state variable, model state variable. However, the property cannot change its value during the simulation. It has to be initialized. So let me just, I'm gonna call it truck capacity. How's that? Okay, truck capacity, and this is 8 to start with. Okay, over here, back in the facility, we say, okay, here, instead of saying 8, I'm just going to say truck, capacity. Is that okay? Same thing over here. I'm going to using the same capacity. So it's the same deliver truck, so it is similar. Question for me so far. Okay, I'm going to make a list a little bit looking a little bit nicer. I have downloaded several 3D model, okay, from Google Sketch. You should be able to. Okay, so it's a little bit too big. That's okay. It's too big. It's just, oops, scale it down. It's just for the illustration purpose. Make sense? And you can take a look in the 3D. That's the truck I have. All right. Also change the deliver truck. I'm gonna input it. Just downloaded this morning, so they're still fresh. Actually, the thing is that this deliver truck is heading downward, so I'm going to rotate 90 degrees. Okay, so make it, and also kind of shrink the size a little bit. Actually, it's, let me take a look. It's wide. Didn't like it, so let me do it. Okay, and then doing a purple truck. How's that? Okay. So kind of pink truck. And this source, okay, what is the inter-arrival time for the big delivery? It should be random. Is that uniform? Yeah, it's uniform. For 160 to 250, I remember, I guess. Let me double check. Yeah, 250. That's the inter-arrival time. Okay, so each time the truck coming in, it got separated into 64 of them. In that case, I can actually say 8 times now truck capacity. All right. Questions so far? And I need to take care of the source. This source is generate the delivered truck, and that source generate actually the semi truck. But the source number 2 generate delivered truck, they only need to generate one time, because this part I'm simulating the return of the truck, so I only need generate whatever total number of fleet I have. So here what I do, basically, I'm generating, okay, inter-arrival time is 0, which is upon the initialization or the starting of the simulation, I generate 3 trucks. And I'm only allow 1 maximum arrival. So they generate one time and that's it. The first time they generate 3 truck, and that's all the 3 truck we have. Okay, so this source is only used one time, and then the delivered truck get forwarded to Crossdock combiner, and then after that they keep recycling around. Question for me. So let me fix a few other things. What is the unloading time, I think? Oh, PERT. Okay. So on this, actually, the processing logic's pretty simple. I've done this many times. It's random PERT. What is it? 15 to 30 minutes. 35. So on and so forth. How about the warehouse is also loading time, a little bit higher, same thing. How about the crossdock? Crossdock is slightly faster, correct? Similar. Let's do this. 10 to 20 minutes. It's actually half of 20 minutes. Most likely 15, I think. Yep. Something like that. Question so far? Other than that, it is done. The whole thing. Refrigerator. Changing the and you can download your own pictures or 3D model. This is the okay, so let's take a look. The refrigerator is pretty big over here. I'm probably just changing the color of the refrigerator to kind of green, so we kind of visualize that. And make it smaller. Okay, you see there are trucks coming in initially into the parent side, 3 of them, okay? And slowly the semi-truck is arrival, so I'm going to speed up a little bit. So now semi going a little bit faster. It takes time to actually unload. You say, I don't see it. Actually, you just need to make it larger. So now you see the semi trucks leaving, and some of the refrigerator coming this side, and some of them coming this side to the warehouse. Question? I haven't filled out all the detail, but I just wanted you to see right now without any decision on these 2 transfer no, we didn't forward the correct number into split the correct batch into warehouse or the cross dock. And also you see that once this trucks come back, sometime it goes to cross dock, sometime it goes to warehouse. But anyhow, this is one of the thing I get you started. Make sense? Okay. In order to determine how many refrigerators actually go into the cross dock initially, or how many goes to the warehouse initially, I'm just going to illustrate that. I'm going to let you to determine how the return truck is supposed to be going either to the cross dock. Let me reread this thing one more time. Homework. Okay. When the total capacity of the delivered truck waiting at the cross dock plus the A for the staging area, so I'm going to leave A, and minus the number of refrigerator en route to the cross dock. Okay, so why don't we do this first? See how that, and plus the number of refrigerator already waiting in the cross dock. So I need to translate these 3 things into a function. We've done this with the memory assembly portion. Stop this over here in the definition. I'm going to define a function, and this function I'm going to call it crossdock. Crossdocks. I'm sorry. Okay. So-called function crossdock. Capacity. Okay. What does this function looks like? Here in the expression, first I want to say number of delivered truck, total capacity of a delivered truck waiting at the cross dock plus 8 of them. Okay, so let's do this. What does that mean? So capacity. First I need to know how many trucks we have waiting in the capacity. So here, maybe I using this expression. So here I have, what is it? Combiner, crossdock, what is it? Parent, input buffer, okay, content, and number of waiting. Okay, this is say how many truck we have in the parent input buffer waiting for to be n plus 1. For these, I'm gonna have, oops, sorry, a times that. Okay, a times whatever number of truck waiting in the parent node, parent input buffer, and plus one of them, m times a. And this a can be translated also to be what? Deliver truck capacity. Can we? All right. So that's the first part. Let's see if we have everything. Should I say that's truck capacity? I'm sorry. Type it wrong. Didn't remember the name. So just truck capacity. So the first part is correct. And then the next thing is what? Minus the number of a refrigerator en route to the cross-dock. How do we do that? One more time. I'm going to say minus what? Combino deliver truck. What? Member input travel number of traveler and say routing in. So what does this mean is in the cross-dock combiner, member input, which means the input node of the member, and number of traveler routing in. So that means over here, this part, number of routing in. So it's on this path. Member of the cross-dock combiner, input node, and how many routing in on theirs. The third one, what do we have? Third one is plus the number of refrigerators already in the cross-dock input buffer. Oh, this is easy. Let's do that. So I'm going to plus, what is it? Combiner, cross-dock, correct? And member, input buffer, content, number of waiting. So these three actually add up together. Okay, so first is equals to the number of a refrigerator taken to the cross-dock equals to the total capacity of the delivered truck waiting at the cross-dock, which means plus 8 of them. Okay, A for the staging area. So basically means this number of trucks waiting in cross-dock combiner, parent input nodes, content, number of waiting, plus 1. Second, minus how many already in routing, so minus the number of refrigerator routing into the cross-dock, basically is cross-dock, combiner cross-dock member input, number of traveler into routing in. And the final is how many in the input buffer waiting. All right, how are we going to use this? Over here, now it's easy. First, at this transfer node, instead of using shortest path, I'm going to using by link weight. So over here, I didn't fill in the proper travel time. You do that. Here, all I have to do is say function travel first stop capacity greater than 0. Make sense? Okay. If this is greater than 0, we're fine. So here the link weight is much more simplified since we have all the complicated calculation using a function. And over here, this time path, I'm just going to say function less than or equals to 0. Is that okay? So I'm going to start running this one more time to show you the truck coming in, making a little bit faster. Okay. So this is pretty much what we have. I don't know how many, if this split is correct or not. Very simple. Click on the combiner, choosing a status label. And the status label is attached to this combiner. And all I have to do is what? Member, member, input buffer, let's type input buffer, and content, number of waiting. Okay, I'm going to actually make a copy of that for the other one. Again, I'm going to highlight this, choosing a status label down here again. And for that warehouse, I'm doing the same. Okay, here I'm going to changing the color a little bit so I can see, get a bit better visualization. All right, let's see. Okay, you see that only have A actually left over for the staging area, and the truck is loading one by one. So this is pretty much what I have. The only thing I have left over, haven't decided, once the truck come back to this transfer node, it needs to determine if he goes to the cross-dock or goes to the warehouse. Okay, I will probably try to do something like here, and you figured out the rest. And here, since I need to see if there are any refrigerator waiting in the cross-dock. So this is combiner, cross-dock, what is it? Member input buffer, correct? Content, you already know this. And number of waiting is greater than 0. I'm going that way. If this is what? Less than or equal to 0, I'm going to warehouse. Make sense? And this thing has to be, make sure you forward them by link way. However, even though actually the this part is less than or equals to 0, still it's supposed to go in that way. But if warehouse capacity is also empty, and still the truck's supposed to go down that way. So I would let you to figure this one out. I would give you a basic condition. If the cross dock is empty, going to the warehouse. If cross dock have something coming down here. But you need to figure it out if warehouse also empty, they're still coming down to the cross dock. Question for me. That's pretty much it.